Next, we're going to talk a little on the test for overall model significance. But before that, let me talk about the partitioning of the variance, which you have seen a little on this, but the variance of a regression can be partitioned into three: the explained variation, the unexplained variation, and the total variation. We have seen this before, but SSR is the sums of squares due to regression, what is explained by the regression that you have. SSE is the unexplained, is the error. So we have seen SSE as the actual minus the predicted squared. SST is the total variation. So SST is basically the actual minus the average. So if you have, let's say, the prices, and you take the actual price minus the average price and square that, that's called the total variation of the variable price, market value of the homes in thousands. Now, this value doesn't account for any, it's not going to change by predictors. It's just depends on the values for the y variable. But out of that, you can take some explained and some unexplained, SSR and SST. Each one of those has some degrees of freedom. The degrees of freedom for the unexplained we have seen is the error degrees of freedom, and that's n minus k plus 1, where k plus 1 is the number of beta parameters. Now for SSR, the explained variation, the degrees of freedom for this variance is just the number of predictors. Okay, and then if you sum the two, that gives you the total number of predictors. Let me just go over this so that you can see it better. This is best seen in the analysis of variance table. So when you run the ANOVA function, that gives you all of this partitioning, and what you see here is SSE divided by its degrees of freedom. So you have SSC, degrees of freedom, which is n minus k plus 1. And then what you have next is SSR, and the degrees of freedom for SSR. The output that you get in the ANOVA table gives you SSR per variable. So it's going to be SSR for square footage, and then we mentioned this before that this is SSR for house age given that square footage is in the model, so it's an additional contribution by SSR. You can see that the SSR for square footage is really large, and then the additional contribution for house age given the square footage is in the model is just a tiny bit more, so it's not significant. So what this is telling you is that given the square footage is in the model, we don't see that much additional contribution of house age. So that's the reason why you have an insignificant value. Does that mean that house age by itself is not a significant predictor? No, it does not. It just basically tells you that given the square footage is in the model, you don't really need that variable because it doesn't contribute that much. So basically, these partitioning of the variance tells you that. Okay. Now, there's a global test for significance. That global test, the null hypothesis is that the predictors are not significant, none of them. So the first predictor, the second predictor, up to the kth predictor, all of those slopes are 0, basically meaning that none of them are important statistically in the model. The alternative is that at least one is significant. So for this market value example, we just have two predictors, and basically the null hypothesis is that both of them, house age and square footage and house age, are not significant. And the alternative is that at least one. The test statistic is going to be SSR over K, which is called MSR, divided by MSC. In other words, the average explained variation divided by the average unexplained variation. That's what we call the F statistic. So let me just get back and show you these values again. Let me run this again here so you can see it. And I'm gonna show you these values here. You see this F statistic is 24, and then that's MSE divided. So again, let me just position it better so you can see this F statistic here, 24.4. That means that MSR divided by MSE, the average explained over the average unexplained, is about 24.4. So that means that that ratio of explained to unexplained variation, the average of those, is about 24. You can see the degrees of freedom for the number of predictors, which is 2, divided by the error degrees of freedom, which is 39. And basically, that's telling you that this is significant. In other words, we have enough evidence to reject this null hypothesis and conclude that at least one of them is a significant predictor. Now, which one of them is a significant predictor? Well, we can see that square footage is significant by itself, and we can see that this is a not, so that's what the test is telling you. At least one of them is significant, and you can see that one of them is. So that p-value is obtained from the F distribution. The F distribution is a right-skewed distribution that contains 2 degrees of freedom, the numerator and the denominator. In the numerator, you're going to use the K number of predictors, and then in the denominator, the errors. This is done automatically, so you don't have to do these on your computers. But just to show you this distribution, it looks like this, and it's right skewed. And basically, we're trying to see if you get a 24, how does it, what's the probability that you get a 24 or more? And that's, you can see that these values right here for most of the distributions are close to 0, but if you get a 24, it's, in this case, is very far away from the, the null hypothesis, meaning that that none of the predictors are good. So we find that at least one is good. So that's where it comes from. So the conclusion in this case is that we reject H null in favor of the alternative. So there's significant evidence that either size or the age of the home is a significant predictor in predicting the market value of homes.